This is Tim Sixton. Today we'll be sharing the results of our project. The problem we explored was the public youth housing vacancy caused by a mismatch with actual demand. Originally, we planned to compare a few areas and design the best housing type mix. But due to data limitation, we focused on one simple question. If we could build just one more unit in Dongjakgu, where should it go? Accordingly, we focused on collecting location and population data and applied integer programming with weighted values. This is a brief overview of our project. Our initial hypotheses were as follows, but since our goal has changed, we came up with new hypotheses. Now let's go over the model. We used binary integer programming, where each variable shows whether a certain dong is picked or not. Our objective function is as follows, and we also added a constraint to make sure that exactly one dong is selected. Now, you might wonder how we got all the scores for each area in our function. We calculated the final score for each neighborhood in Dongjakgu based on 4 key factors: youth population, marriage activity, subway accessibility, and university proximity. We also set the weights like this, and we counted the population as the total number of people aged 19 to 39 in 2025. And for newlyweds, we added up all the marriages from 2018. For location factor, we based our model on the number of nearby subway stations, the location of universities, and student enrollment. So let's start with the youth population score. Sangdo-dong was the benchmark since it had the largest, and we assigned normalized scores to other areas. Heuseok-dong had the least, so it got 0. And we did the same for marriage activity. Sadang-dong was the benchmark, Sangdo-dong came second, and Shindaebang-dong got 0. For a subway score, we assigned based on the number of stations within and those adjacent to its boundary. Shindaebang-dong had the best subway access, so it got the highest score of 1.5, while Heuseok-dong received the lowest. Finally, we scored university proximity based not only on location, but also the student size. Chungang University was the baseline, and the other got relative scores. The neighborhood with the highest score was Sangdo-dong, followed by Heuseok-dong. Finally, we gave the highest weight to the youth population score. Then we added up the weighted scores for each neighborhood. Sangdo-dong came out on top, so it looked like the best fit for youth housing. We tried 2 other weight combinations as a sensitivity check, and Sangdo-dong stayed at the top no matter which factor is prioritized. So naturally, we expected the most youth housing to be located here. However, in reality, only 1 out of existing units is actually located in Sangdo-dong. This shows a clear gap between the data says, what the data says, and what's actually happening. Decisions might not be driven by real demand, but rather by what's easier and more feasible. Such practice can lead to more vacancies and less satisfaction. Going forward, we want to understand why areas like Sangdo are being overlooked in real policy. And in the long run, we hope to propose tools that consider both feasibility and real demand. This project was a collaborative effort of all team members, and thank you for listening.
질문 없나요? Okay. Very good presentation, and I have one question. How did you choose the weight, alpha, beta, gamma things?
So there were four weights, and we consider that the population is the factor that has the most importance. So we highlighted that weight the most, and other marriage activity, subway accessibility, and university proximity. We thought that these indirectly affects our model, and they relatively have less importance.
Oh, okay. So, did you try another weight?
Yes,
Oh.
we did the sensitivity analysis. Maybe that was not explained thoroughly. So we did use 0.6 scenario. We had gave more 0.2 more score to that, and Sangdodong was highlighted on that data. And for the transit, meaning subway accessibility, when we increase that way, then 침대방도 exceeded 노량진.
So this is IP model. You have sensitivity analysis.
Mm-hmm.
How did you get the sensitivity result?
What do you mean by how did we get?
Oh, you used IP model,
Mm-hmm.
which cannot provide sensitivity analysis result.
Hmm?
So
This is for the weights.
You ran all the models
Yes.
and compared them by using the graph. Okay. Manually.
Yes.
I see. Good. Okay. So, interesting. Thank you.